Hey, it's Brandon Stiles, and today I'm going to show you how to do binary search in JavaScript. Now, if you're going through coding interviews, binary search is going to be one of the kind of low-hanging fruit algorithms that you need to come up with, right? The most important things usually in algorithm and programming and software development is going to either be sorting an array or a list or something like that, and searching through one, right? You have a list of clients, you need to search through them. How do you do that fast? And how do you find indexes and all that kind of stuff? So today I want to kind of take a little bit of the hardness out of binary search. A lot of people look at search algorithms and sort algorithms and are like, oh my gosh, I don't really know what to do. It's not that bad. I'm gonna try and show you how I think of it in an easy way that you can think of it too to get better at algorithms as a whole. So let's dive on in. I'm gonna open up VS Code and let's get to coding a binary search algorithm. All right, before we dive into coding binary search, let's talk about what it is. If you already know what it is, then you can skip ahead. I'll put a timestamp below. But if you don't know, let's take a look at it. So I'm going to draw an array real quick. Now the key about this is that it has to be sorted. But the good thing is, a lot of the times when you're dealing with web work and front-end work, a lot of the data will probably already be sorted. So maybe you could take that as for granted. But if it's not sorted, you've got to sort it before you run the actual binary search. So let's say I had an array and it was sorted, and let's just do an easy one. Let's do 4, 5, 6, 7, 8, 8, and then 9, just to make this easy. So binary means yes or no, true or false, 1 or 2. Or more accurately, 0 or 1, okay, true or false. So what you're gonna do with binary search is you're going to pick a number in the middle of your array. You're gonna program that in. You're gonna program your code to find the middle number, which in this case would be, of course, 5 right here. So then, once you pick the middle number, your code is going to check first whether this number is the number you're looking for. So let's say you're looking for 2, okay? So is 5 2? No, it's not. In fact, 5 is higher than 2. So if 5 is higher than 2, you know none of these numbers are going to be the number you're looking for. So rather than checking every number, right? So is 1 2? No. Is 2 2? Well, yeah, but imagine you've got a million elements. That's going to take forever. That's going to be linear time right here, right? Big O of n. Rather, binary search, each time it does an iteration, eliminates half of the array. So in this case, it eliminated 6, 7, 8, 9. And then we're going to run this, in this case, recursively. So it gets to the end, and then it's going to go in again. That means recursive is going to try it again. So it's going to pick the middle number left of this array, right? So these are gone. So it's going to pick the middle number here. And it's going to say, all right, 3 is, first of all, is 3 2? No. So it's going to say, all right, is 3 higher or lower than 2? And it's going to say it's higher. So it's going to eliminate these numbers. 3 is going to be the new endpoint, and 1 is going to be the new beginning point. Well, the same point it's always been, and it's going to check one more time for this. And of course, now the middle number is going to be 2. And if it checks if the middle number is 2, 2 equals 2, that's good. And so then we will return that. Yay! So that's how binary search works. Each time it iterates through recursively, is what it's called, recursion, it makes this array smaller until it finally singles out this number. But the good thing is that instead of running in O of n time, which is fine, but we don't want that, we now get O log of n, and it's just a lot better to work in. So now I'm going to show you how to code that up. Let's jump over to Visual Studio Code. Pop back over to VS Code here. Now let's go through coding up binary search in JavaScript. Let's do a few subnotes here. So remember, the time complexity is going to be O log of n, and then our space complexity is going to actually be O of 1. It's going to be consistent because we're not actually creating anything new, right? We're just going iteratively through an algorithm. Remember, this is going to be the recursive version of binary search. You can also do an iterative version of binary search, but this is going to be recursive. First of all, let's summarize binary search. Essentially, what you're going to be doing is you're going to find the midpoint of a sorted array. All right, so again, let's say it's this right here. All right, so you're going to find the midpoint of that sorted array. Then you want to throw out the half of the array that doesn't contain your number, right? Making it a lot smaller. In fact, you've eliminated your choices by 50%. The computer has to do essentially 50% less work. So let's go ahead and code this out. So we know that we're going to need a function. So I'm just going to say let recursive binary search equal, and we need to give it 4 things. We need to give it an array, a number to look for, and then of course we need to give it a start number and an end number. Right? It's got to know where it's going. So these are the things we need to give it as arguments. Say, hey, we want to do recursive binary search, and here's an array, here's a number we want you to find, here's the start number, and here's the end number. All right, so let's pass those in as arguments right now. Cool, so there are our arguments. Now let's pass it into this baby right here. I'm just going to end this up. Now remember, there's a couple of things that we want to make sure of when we're working with binary search. We want to check that it's sorted. Right? It doesn't work if it's not sorted. We would have to sort it in that case. And we also just want to check that it's not null, or that the array is not empty, right? If the array is empty, there's no sense doing any work on it because we're never going to find the number. So next off, we need to actually find this midpoint of the sorted array, all right? So think of this as like step 1, and this would be step 2. And then step 3, and this is where recursion comes into place. Go to step 1 and repeat. It's like a shampoo commercial, right? Rinse and repeat when we're talking about recursion. All right, so the next thing we need to do is we need to find the midpoint of the sorted array. All right, so that's what we're going to do here. We're going to find the midpoint of the sorted array. That way we can kind of set either a new start or a new beginning to our array. Now, what would the next easiest scenario be? Well, the easiest scenario would be if that midpoint was the number we're looking for right here. Like say the number was 7. Well, if the midpoint number was 7, then we don't have to do any more work and we can return out of that. We're good. All right, so let's just write that as like a little check. If midpoint is number we want to find, then remember this is a function, so we need to return something. We need to go back to the main code, the global code over here, and out of this little block right here. So we're just going to, let's just say return true for right now. So we've got our midpoint. So if the midpoint is greater than the number we want to find, all right, let's write this out. Let's just give us an example. Here's an easy one. So this will be let an array equals that, and let the number we want to find equal 2. So if we find the midpoint, which in this case is going to be 4, that's the midpoint of the sorted array, but the midpoint is greater than 2, in which case it is, that means that all of these numbers are going to be worthless, right? 5, 6, and 7, and even 4 are going to be worthless. So we want to move the end. So it could still be any number over here, but it can't be any number over here. So we want to start this operation over, but eliminate all these numbers right here. All right, does that make sense? So if the midpoint is greater than the number we want to find, we're going to run it again, but the middle number minus 1 will be the new end number. Right, so now we're going to cap it at 4 instead of capping it at 7. So all these are going to be gone. So instead of this, it would essentially be middle minus 1, and it would run it again, and it would just keep eliminating numbers. All right, so that's basically the algorithm. Let's check that out. Now, what do we do if it's less? Okay, so if midpoint is less than the number you want to find, then run the whole thing again, but middle will be the new start number. So we would run this again, but the new start number would be right here, and then the end number would go as it was, right? That would mean that none of these numbers down here are going to be valid, so we can start it again using just this number and to the end. So that makes sense. Let's go back to start here. That's really all there is to recursive search. So all we need to do now is fill in this stuff. And for the future, when you're thinking of a recursive binary search or any sort of algorithm, whether it's search or sort, a lot of times it helps to kind of code out the logic, and then we can go from there. First, we want to do this error checking right here. So what I'm going to type is so first of all, let's check that it's not null. So if array.length equals 0, or start number, let's actually change that to start number 2. Start number is greater than end number, because that would mean it's not sorted, right? If this was a 9 right here, then we would automatically know it's not sorted. So that's a quick way to check sorting. Then we want to just break out of that. We want to return false because nothing else is happening. That we don't even meet the conditions that are necessary to run recursive binary search. So let's just break out of there and save our CPU some runtime. Now we need to find the midpoint number. So we want to let middle number and we want to set it equal to the midpoint of this array. So how do you find the midpoint of a set of numbers? Well, we need to do start number plus end number divided by 2. But be careful here though, because what if your array is an equal number of elements? Let's say it was 8. So the midpoint here is going to be 4.5. Now we don't have 4.5 in our array, so we need to either take this element or this element right here. So we're going to need a little bit of math.floor so that we can, or math.ceiling, whatever have you. I'm doing math.floor here so that we don't have a floating point number. It's actually just a discrete integer. So we're going to let middle number equal math.floor of all this stuff right here. And now we have found our midpoint, so we're looking good. Now we need to check this. So if the midpoint of the array is the number we want to find, all right, so if the array at middle number equals number you want to find, return true. All right, well that's easy, return true. If the midpoint is greater than the number we want to find, all right, so we need to say if array at middle number is greater than the number we want to find, run it again. All right, so we want to return, and then we want to run it again up here, recursive binary search, but middle minus 1 will be the new end number. All right, so we're going to still pass it the same array, we're going to still pass it the same number we want to find. We're going to pass it the same start number, but this time we're going to give it the new end number, which is going to be middle number minus 1, right? So if in this array, let's say this was 9, the middle number is going to be 5, but we know it's not 5, so we're going to start it again from here. So now really it's like checking an array that's like that. And then it's going to find the middle number again of this using math.floor, and then it's like running it again and checking the number of that. And it's really quick to check a 2-number array. But anyhow, all right, now let's deal with this last edge case. So we're going to say else, because this is our last option. We're going to return, and this is a recursive return. So let's type recursive binary search. We're going to run it again because we still haven't found that number. But this time, the midpoint, this is handling if the midpoint is lower than the number we want to find. So if the number we want to find is 8, but the middle number is 5, we know all of these numbers are going to be eliminated right here. So the next time we run this, we want to start at the 6. So even the 5 will be eliminated because 5's not, the middle index is not the number we're looking for. So the next time we run it, we're going to start at this 6. So again, we want to pass it the array, the number you want to find. This time the new start number is going to be the middle number plus 1, and then the end number is going to stay the same. And that's all there is to it. That is binary search. So again, it's just picking a midpoint, checking if it's higher or lower, and then eliminating the other half that is not. So that's all there is to it. So if you wanted to check this, we could write out a little program. So we run recursive binary search, and then of course we pass it the array up here. So we're going to be passing it this 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to pass it the number we want to find, which in this case is 2. So number you want to find being 2. And then we want to pass a starting number, which is 0, right? The 0 index of the array. And then the end number we want to pass is array.length minus 1. So that we go all the way to the last number. So if that's true, we want to just, let's say we want to log something out. Let's do a template literal here. We can say nice. Nice. The number you want to find that'll print out when we log it was found in your array. That's good. Else, we want to say sorry, it wasn't found. And that's it. So in 40 lines, and even less once you take out the comments, you have coded binary search. So just to check this, let's save it. I'm going to copy and paste this into a little runtime environment. So we want to see if 2 is in this array, and it is, so this should return true. So I'm just going to copy and paste this. Nice, it was. Now let's take 2 out of this and see what it says. Sorry, your element was not found. Awesome. Let's do some checking. So let's make the length of this 0. Then it says, sorry, your element was not found. Let's see if it works with an even amount of numbers. 6, 7, 8. It works. And then let's change this to 5.5. Sorry, element's not found. So we have successfully coded binary search. Good job. If that was helpful, please subscribe to this channel. It keeps me motivated to keep making coding videos for you. And we'll see you next time. This is Brandon Stiles.